Hello everyone, this is Sumadr Shakya here. In the last video we covered location allocation when we came across a couple of ways as to how to decide on the best location given the criteria of either maximizing market share or minimizing the impedance. That impedance could be the travel time or the distance. Now in this video I'm going to show you how we can use a vehicle routing problem wherein we assign a starting or the ending depot for, let's say, a truck, and then the truck is supposed to go out. Let's say if we were to choose one of these as a starting video, then we were to assign a certain set of routes by which it is supposed to deliver, let's say, the product and then come back either to the same or to a different end depot. Okay, and then we may have a different route or such that every route is started by represented by a truck, such that it will travel with the actual roads, deliver to the assigned ones, and then come back to either the same route or a different depot at the end. Now there are a couple of parameters that we can assign such that because in reality, I mean, if you were to go by linear programming, then the constraint become too complicated. So the software allows us to do a lot of solving in relatively easier manner. Relatively easier because if you were to do this mathematically in a statistical program like SAS, Tableau, or a Lingo, or other such programming tools, then it becomes a lot more difficult compared to what we'll have to assign in the software to do it. So to again, basic things, we have two sets of points, one being the hotels and hospitals, which still looks something like this, when we have the unique IDs, we have the names, and this is very basic simple data set. And then for the potential candidate location, again we have the unique ID as their names. Now in theory, if you were to look at the properties of a depot, you can assign either one of them as the depot status, and you can say that, let's say this one is the starting one and let's say this one is the ending one. Yeah, but I'll show that in the next video. But as of now, I'm going to show you the basics just to show you as to how to get the tool into the action. Okay, so we'll just begin by starting to use the tool, and then later on we will proceed with the level of complexity. Okay, so first thing is I'm going to go to the system toolboxes, go to network analyst. Within network analyst, I would go to analysis and choose the layer or the tool called make the vehicle routing problem layer. Okay, now there are three components to this that are essential. One is the set of the target points, or the orders as they call it. The next set of point is the depots. Depots are the starting or the end point, so starting or the end point. And the third component critical is the one that joins these depots with orders, and those are called as routes. Routes can be taken as proxy for a truck. So one truck is different than the other, so you'll have to name it as truck 1 or route 2. Orders will have their properties, for example, the start time or the delivery quantities, the pickup quantities, the window of receiving the truck, window of receiving. Now you might be able to give them two windows. One is the preferred one and the second one is, let's say, 2 hours after this, so another acceptable start time. And the same thing for this, there would be an end time 1 and then end time 2. Similarly for depots, you would have, let's say, the name, the capacity for supplying or how much can it hold. Similarly, the truck will have their own capacity field. Now the specific names in the tool might be different, but I'm giving you the general concept. The starting depot has to open at certain time when the a truck would start from the depots, go around the orders, delivering and picking up the leftovers until and unless it has the capacity, because you cannot exceed the capacity of the truck and then come back to the same or a different ending depot. Okay. So with that, let's start with our first one. So when you double click that, this is um, the window that shows up. So input analysis, this is our network that we created from the road network, and then click yes. Vehicle routing name, I'm going to call this base vehicle routing problem basic 1. Okay. Something to differentiate. Time is going to be calculated in m minutes, so I know this is the field that I created, not created by the system. The distance is also, I'm going to use m miles, and the dimensions for the measurement of this field is minutes. The dimension for this field is in this units. These two are system understood criteria. So I know this is not calculating on some number that was theoretically created in seconds or hours, that this software is considering as minutes. So in order to avoid that confusion, I created my own fields where I know that whatever number is in this field in the file does represent minutes, and therefore it is okay for the software to consider this as minutes. Okay. Then the default date is currently not something we need to be concerned about. This is when you have 3 or 4 work days in the week, and you are trying to be conscious of the fact that some of the depots will be open only from Monday to Wednesday, and some others will be open on Saturday and Sunday. But as of now, for the sake of simplicity and just to get started, we will ignore that point. Capacity count, as of now, it's optional, and I'm going to leave it as is. So then we have least of restrictions in order to start creating the layer. Okay. Hierarchy, we'll leave it as default. Output, true lines without measures. I'm going to say true lines with measures. Okay. And any restrictions, I will say allow U-turns. Okay. Now this is for the sake that when we were building the network dataset, I already allowed U-turns in the network dataset itself. So had that not been the case, this option would be meaningless here. Especially this is when, let's say, if you are making a very realistic scenario, it will become more detailed and therefore more data intensive. However, it is mainly for the fact that instead of any network streets, when I've used city streets and highways, all of them combined, and if you were to use semi-trucks for your analysis, then you have to use truck routes only and not the city streets, not all the city streets. So in those cases, you will say no U-turn, because it's very cumbersome and dangerous for the driver of a semi-truck to perform a U-turn. It's only a matter of time when it the things gets south. It's not a matter of if, it's a matter of when. So that's why these these options exist. But as of now, we will, for the sake of simplicity, I'm going to say allow U-turns and hit OK. Now the moment you do this, there should be a new vehicle routing problem window generated here, and it's not visible to you, but there's a small icon window that shows up on a different screen on my monitor, but it should show up somewhere on the bottom right like this. Oops, like a rectangular, and it should come up with a tick mark saying created successfully. Yeah, vehicle routing problem created successfully. Okay. Now in this case, I am going to say that my orders are going to be by loading the locations from hold on, let me show it to you where my orders are. So my orders would be the hotels and hospitals. Yeah, continuing with the same example from the previous videos. I do have a lot of other files which you can ignore for now. This is my orders, this is my depots. So I'm going to say load locations and go to the file name of hotels and hospitals. Hotels and hospitals. Within the hotels and hospitals, I'm going to say sort them by OSM ID and name them as OSM ID. Okay. Now you see, if at this point, these are the things to keep in mind in moving forward, that these are the properties you can provide for the orders. You can give them the description, service time, the time starting window, the opening time of these hotels and hospitals, and the ending time. If these two are not met, then what is the second best option the software should give you the optimum value for? The second best starting time and second best ending time. The next thing you have is violation time. Let's say if the truck does not get to the starting end time and end time 1 and end time 2, then how much violation of time is allowed? 15 minutes, half an hour? So it goes basically as a goal programming instead of strict linear programming, wherein if the condition is not met for subject to constraint, then it comes back with error. Instead, it goes for the second best criteria. So it becomes more like a goal oriented programming. Sorry. And then the outbound depart time, delivery quantities. This is something, had this been one of the attributes, then we could have chosen something here, but as of now we are going with the most basic information that will allow you to start running this tool. Now pickup quantities would be the quantities, let's say the empty bottles or empty pallets that need to be collected by the truck. The delivery quantities, the fresh quantities, the product that the truck needs to deliver. At any given point in time, the delivery quantities plus the pickup quantities on a truck should not exceed the capacity of the truck, which will come back later in the routes layer. Okay. The revenue is something, if you do have, let's say, a field that you can multiply pickup quantities or delivery quantities times a certain cost value, such that the revenue has to exceed, otherwise it doesn't make sense for the truck to come back, type of thing. And then assignment rule, you can say if the truck should approach the facility from a certain direction, like left or right. And then the next one is if you also want to assign the orders to a certain route. This can be taken as, for example, let's say if you are trying to manage an urban traffic situation, then certain locations, certain school points or pickup or the bus stops need to be served by a route number of a bus, let's say 15 bus number instead of 18, and so on. Or if a certain set of beer serving restaurant need to be catered by, let's say, a truck that is driven by Gary and not Tony. Yeah, so this is where this is helpful. And then the sequence is, if you already want to hardcode the order of delivery among the orders. Okay, but as of now, do not get intimidated. Let's get started with, I'm going to say 5 miles. This is only to make it easy on the software, so it'll for every node it will look around for 5 miles, within which if it finds any vertex on the network, then it will considered located on the network. Yeah, so let's go back up. Description, I'm going to choose as name, and that's about it, because I don't have a whole lot of information as attribute of the orders. These are the hotels and hospitals, so as of now I'll hit OK and wait for it to load these points. You see here it will take some amount of time. Currently it's going 3% and so on, so I will come back when this is finished. Okay, so the loading for the orders is finished. Now just to give you an idea as to why does it take so much time, because you see, remember, in terms of properties for the file we only had 3 or 4 columns, wherein once it is uploaded in the orders, it creates for everyone, every row, it creates service time, time window starts 1, ending 1, starting 2, ending 2, maximum violation time 1, maximum violation time 2. So the time starting and ending and violation time, these go together. Then this and this go together. Okay, so this is all this information we could have supplied. In the next video we'll try to supply this to be more accurate and representative of the actual scenario. Now, depending on the scenario that you're dealing with or whatever problem you're trying to analyze, you can become more and more specific with route names and so on. You can supply this as part of the properties, for the hotels and hospital. Now, how can you do that? Now, remember I showed you how to bring in an external CSV file. You can create all of these in a CSV file and join them with a unique ID that already exists in your hotels and hospital, and that is why we created the unique ID. Now the unique ID was used to name these as of now. Okay, so you can certainly join it using the OSM ID. Yeah. Now similarly, I'm going to load my depot points. Now for the depot points, I'm going to say load locations. Now remember, I'm going to show you the attribute tables. These are the only options we have as of now in terms of depot. So when I say load location, I'm going to bring it here so then you can see somewhat. Yeah, I'm going to sort them by oops, this is another depot one. I have to choose the potential candidate locations within which I have the unique ID, and then I'm going to name them by unique ID. Now if your name is alpha numeric, the software will give it its own by default numbering to all of these locations, so you'll have to be careful or be cautious when you're analyzing the results. Yeah, the description, I'm going to choose this, what best describes. I'm going to use it again as unique ID. Theoretically these two can be different, the time starting window and ending window. So just like you had the starting and end time for the orders, for example, there's a time when the order opens, the hospitals and the hotels might open and close in a day. Similarly, you have the same property for the depots, wherein they have the first preference starting and end time, they have the second preference of starting and end time. Okay, the curve approach is wherein for a certain depot, the truck should always, let's say if this is the road, the depot is over here, and there's a barrier that divides the truck. In that case, if in a right-hand driving country like United States, then the truck should always approach from the right hand side and then turn inside, because if the truck comes from this end, it cannot directly go in here, so it has to go around and then maybe take a right turn, make a longer turn somewhere around the block and then come back, because remember it cannot immediately make a U-turn for a bigger truck. Yeah, so that is why all those options are there. Now as of now, I'm satisfied with the bare minimum information that I have, and I just want to get this tool working somehow, and hit OK. Again I see the locations being loaded here. It says 15% done and so on. Again, I'll come back when it is done uploading all these location points in the tool. Okay, now if I was to do this relatively easier way, then I would have created information either in CSV that I could have brought in here, but for routes I'll show you how to start from scratch. Let's say at this time, if I was to have any route layer, I could have added just like this, starting depot, ending depot, and so on. But I'll explain it to you as to what all options do you have. Just like we loaded the orders and depots, we could have chosen a sorting field, which is optional, and then how to identify the name, the description, the starting depot and ending depot. These could be the same points. Let's say in our case, in our data set, I could choose one of these locations, let's say Prunedale 3, as the starting depot name and the ending depot name as well. So that is allowed. And then also the service time. For example, the truck, the bus driver may also have their starting time or reporting time of 7 a.m. Now that may coincide with some of the hotels and hospitals that are already open by that time, and may also coincide with one of the depots that is also open at that time. But this is not always the case. So that is why all these properties have to be defined individually for the orders, and then for the depots, and then again for the routes. And the software will try to match these, the time when everything matches, only then it will serve the purpose. Okay, and then the early start time and the latest start time. So let's say if somebody was to start early or somebody was to get delayed, these two things play into the maximum violation time. If these things were not to exist, then it will become a very strict constraint, and then many times the solution will never exist. And then the capacities, we don't have any field as of now. In the routes layer, this is from one of the older results that I tried and tested before recording this video. And then you also have the cost per unit time. This goes into your revenue calculation. Let's say the cost per unit time was to, let's say if you're paying somebody a truck by hourly basis, then this is where that cost goes. Or if you are also thinking of paying cost by distance for the truck that the driver is driving, then let's say that will go in here, cost per distance, such that it's about 80 cents a mile or $1.50 a mile, depending on the type of truck. Then the maximum order count is the number of orders it will pick up. The number of orders, depending on how you set up your problem, could be the number of orders that are allowed for the truck. So in this case, the way we are setting up this problem, in this case the maximum order count is the number of facilities that will be visited by the truck. So in this case we have 51 orders. The maximum allowed is 30. So one truck will go to no more than 30 different hospitals and hotels. Okay. And then we also have maximum total time of driving for the truck, which is usually you have to take into account that no truck driver should be driving, let's say, for more than 8 or 10 hours straight. And then the maximum total travel time. Why is this different than maximum total time? This is the time of driving, let's say, but there's also the time to unload, and then pick up, and then loading again, and then the wait time. Wait time could be either before the unloading, let's say somebody's opening up the gates and the truck driver is waiting for the hotels and hospital to get the right type of people to check on the load or fill up the paperwork and so on. So the maximum total travel time is usually more, if not the same as the maximum total time, or vice versa. So for example, this one, depending on how the software the fields you chose, maximum total travel time will include the time spent in traveling. The total time could include the delivery, the waiting time, the loading and unloading time. Yeah. And then this is the maximum total distance. This is dependent on the fact that what is the mileage allowed for a truck. Then the specialty names, not something we need to be worried about. Assignment rule is, again, gives us a little more freedom as to what all things can be served by more than one truck. Okay. So at this point, I don't have any of the layer that is set up for this. which I'll try to show you in the next video. But as of now, let's say I start with the manual creation of the routes, such that I create this as instead of truck, I'm going to call it T truck. Yeah, and this is truck number 11, and I'm going to represent this in here. Now start time, let's say I want to choose the Watsonville, because from the previous one Watsonville seems to be the better location. Ending depot, I will make this at somewhere in let's say Gonzales. Yeah, so I'm creating start depot and ending depot as difference. Now the start depot service time, you can give it some time. Make sure you give it the exact format that it is expecting you. Colon means that colon has to be there. If a space is there, then that means that you have to provide the space, otherwise the software will not understand. The arrive, depart, delay, and so on. At this point, I do want to put in the capacity, other than, so capacity I'm going to put in, well, since I have not specified in terms of order, delivery and pickup quantity of the orders, this should not be a constraint, binding constraint as of now. But let's say neither do I have a fixed cost. Fixed cost would be before the truck driver shows up. In order for this route to be used, then what is the cost? Let's say I'm going to put in 100. The cost per unit time in this case by default is 1. You remember, if you notice, there is no cost per unit distance, but there is a cost per unit time. This is the by default, otherwise the software, this module will just not work. So what I'm going to do is I'm going to say cost per unit time is, let's say, $8, and the cost per unit distance is, let's say, 2.5. and over start time, I do not have anything yet for this one. Maximum order is, let's say, 25. Total time, since my value was in minutes, I'm going to give it in the same units. Maximum total time is let's say 8 6 or 48, so I'm going to give it 480 minutes, and that's about it. Then anything from here onwards, these will be the results of the parameters that you set up early. So once you are done doing the analysis, this is where you come back and see. Now you can also export this as a right click and export the attribute table as a table, and then do that in the spreadsheet. If this is every time it changes, it's difficult. If you have more than one route, let's say you have 15 different routes, then for all 15 different trucks, it is difficult to see it in this type of window. It's instead, if it is better if you bring all of those 15 trucks out and then compare them side by side, and then see which truck is doing better. Okay, so as of now, now the moment you are done filling out the route thing, immediately this window will become ungrayed, so it will become available. Okay, so at this time, this is one route. I'm going to create one more route, add item, and I'm going to call this as truck number 22. Description Gary. Oops. And start depot name, in this case I'm going to start this from Marina, and this thing has to go to, let's say, Soldad, and capacity is null, fixed cost. This one is little costlier. Cost per unit time is this $9. Cost per unit distance is $3. So overall, this route to Gary is costlier than the other one. Okay, and but this guy can cover more ground, so I'll keep it at 30. And maximum total travel time, I'm going to say this guy works for 9 hours, so 9 6 54, so 540. Then hit OK, and let's say I will go back here and call this description as Tony. Okay, so clear selected features. Now I can uncheck these two layers because the VRP is representing all of them, and then I go and click on this small icon. You remember this is the name that we created, vehicle routing problem Basic1. So this is what I'm going to click on in order to change the properties. Now this is wherein I set up the criteria of the linear programming that is going behind it. So location type, order, you can choose what the description, service time, windows and everything is. I'm going to say let me get to middle, end or shape. So this is wherein, for example, a road is comprised like this. This may be intersection or may not be an intersection, but road is, if you zoom in, it is connected of small nodes. So even though the same 7th Avenue may start from here, may go up until here. So this is the starting point of the road, but then if the truck comes in somewhere on this one, if this is a node, then it says then let the truck go from here onto this road. So either the middle or the end. So even if it gets to the middle of the 7th Avenue, then it should immediately start going to this route. It should not wait for a road such that it tries to find a road that only connects to the starting side and then comes back on the 7th Avenue. So all it does is, all I'm trying to make it is a little easier on the processing power of our software, of our machines here. Yeah. Later on, the more realistic you want, you can choose that way. So, and then analysis settings, day of the week. If you were to given a certain date, then this is where you can choose. But as of now, I'm trying to be neutral to the days. Capacity count is if you want to specify something different. Otherwise, all these should be okay. Use time attribute as minutes, and I do not want this. This is okay. Source, layers, and general. At some place, true shape with measures. This is correct. U-turns are allowed. Miles is fine because our network is based on minutes and miles. Okay. And anything here, importance, medium. Okay, yeah, that's fine. Okay, everything looks fine. And snap to the closest node available, either in the middle or the end. Hit apply, hit OK, and then we ask it to solve. Okay. Again, you pay attention here. How long does it take? So a couple of seconds, less than 10 seconds. Okay, so now if you go back and see the orders, all those orders are assigned between the two trucks that we created. So all of these from location name that we chose, all these names of locations are served by truck number 11, so 25 of them, because that was the capacity of this truck, you remember, for Tony. Now then for truck number 2, it had the capacity of 30, but it made more sense for some of the locations to be assigned by Tony versus Gary. Yeah, so you see, so from here till here, all these locations are served all these highlighted locations are served on the map, including this, from the starting point that we assigned for truck number 22. Also, if you look at the properties here, so this is the full route for truck number 11. So I'm going to click on the properties. So this Tony guy had the option to serve no more than 25. Yeah, let's say this you start to pay this guy differently, and then now instead of 20 he can serve 30. Yeah, then again I'm going to go selection, clear selected features, solve it again. So pay attention here, truck number 22. Yeah, okay, so now only one more location was added to it in terms of the counts. Now it could have exchanged a lot of different set of location out of those 26. So even though this Tony can now serve 26, but not all those locations. So if you remember from the last time, these 3 locations has been given to this now. These 3 locations have fallen on to Gary now. Okay, so let's see here, clear selected features. Now if I go to truck number 11, see how it, so this was our starting point. Yeah, so this Watsonville was our starting point, ending point was in Gonzales. So it goes on to certain location in certain order, then it goes back here. On the contrary, this guy Gary starts from Marina location, serves all the hospitals and hotels on the route, goes on up until south in Carmel and south of Carmel, and then comes back to Soledad, I believe. Yeah, I think that's what I assigned it. So now the thing is, other than the visual thing, let's go on to the properties. So first thing, the truck number 11, the guy named Tony, he traveled, he visited 26 locations, because each location is considered as one order. So he visited 26 total number of hospitals or hotels at the total cost based on what we assigned, cost per unit distance, the cost per unit time, and the fixed cost. This is the total cost. This is the regular time cost. Overtime cost we did not supply it, therefore it's 0. The distance traveled is 196. So if I supplied cost per unit distance 2.5, that means 196 divided by 2.5 is the number of miles it traveled, which should be given over here. Yeah, so what it is saying is 78 times 2.5 is what should be this one. Yeah, I hope. Yeah, that's about it. And then the cost per unit time is again the start time, the end time, the total travel time, and then the total travel time, the plus what we assigned here, the top above this, as to cost per unit time. That's how we got the total travel time and the cost of that total travel time. It started at 8 a.m. in the morning, okay, by default. End time, it started soon enough, was done soon enough without violating any constraints. Okay, now theoretically, if I want to run more analysis, but I do want to keep this for my records, now what I'm going to do is, here for the orders, I will check which of them reached where. So first thing, all these orders are given either of the 2 trucks in this scenario that we analyzed, truck number 11 or truck number 22. The sequence of visitation is here given. Then the violated constraints we didn't provide, so we didn't get anything out of it. From previous distance, cumulative travel time. So this is from the last order that it visited, how long did it take to arrive at this certain particular location. Okay, that's what the these 2 fields are: previous travel time and previous distance. Okay, both in terms of time and distance. Then the cumulative travel time that the truck has traveled by the time it reached this point of order, either that particular hotel or restaurant, it had already spent 33 minutes of driving. By the time it reached this location, it had spent 97 minutes of driving time. Yeah, so I will say this one. Yeah. Approach, we did not restrict, so either side of the vehicle is fine. If the truck was to be such that it only has a delivery door on one side, then we need to specify these restrictions as well. This is an actual date and then time, so it is taking on the system time because we did not give any date, so it took the today's date. Okay, so let's say if I was to show you, so it is 9th October 2017, 9:37:39 a.m. So this is how long it took to reach. This is by default information, wait time, violation time. We did not provide those information, therefore we are not getting anything out of it either. This is position along the network and so on. Status okay, which means it was visited and no conditions were violated. Because many times, let's say if you have 10,000 locations and there's a constraint that the truck cannot reach everything, every order, then in this case you will see the status as something other than okay. Okay. Now let's talk about the depots. Okay, in terms of the depots, we will see somewhere start depot and end depot. Okay, we did assign, so nothing in here, nothing has changed since we loaded on to this one here. A little strange. I was expecting start depot chosen. Maybe it's because we manually created the routes. Okay, so then the last one we've already discussed, the routes. This is about the truck themselves. So Tony and Gary, they started both at the same time, 8 in the morning, ending such that the latest they can start in the morning is at 10 o'clock. So delay of 2 hours is allowed. Fixed cost we assigned $100 for Tony and $150 for Gary. Okay, and maximum order count, they both come in. First I had allowed 25 for this guy here, but then later I changed it to 30, so that's what we have. Maximum total time 480. Maximum total travel time assigned to Gary was 540. So I tried 2 different, and then assignment rule, they need to be included. Order count 26, 25, this is how much they're serving. This is the total cost for each of them. This is the regular time cost, and then this is the regular distance cost. Okay, depending on the service window, there could be an overtime cost, but it is very difficult to come up with the over distance. Then the total travel time, total distance, starting time, end time, and so on. Okay, violation time we don't have because we did not provide anything. So these are all the details that you can get. Now this is, remember, by without providing a whole lot of information or characteristics about our orders and depots. Now let's say I want to keep this static information for my later use. I'm going to say export data frame, and within my outputs I've created VRP1. I will create another for this demonstration, VRP2. Oops. Oh, I created VRP2 within this. Okay, no, that's not what I want. I will go up one and then create another one, VRP2. So VRPs for, why are there 2 of them? Okay, yes. So within VRP2 outputs, I will save this as my orders, and since I may come back and create another scenario and export them again. I'm going to name them as order 1 and make sure this is shapefile. Yes, this is shapefile. Hit OK. Yes, so that gets added. And similarly, I'm going to export the depots, and I'm going to say depots 1. Okay, yes, and then routes, export data, routes 1, hit OK. Yes, and I'm going to choose routes, orders, and depot, and group them, hit F2 and say demo 2. Okay, now this time if depot matches depots here, orders matches orders here, routes matches routes here in terms of the properties. Okay, now what this allows me to do is I can go back and change certain parameters either for this or for the routes. Yeah, let's say I can say this becomes $5 now, and I clear the selected features and then hit solve. Now this might change everything for orders, depots, and routes, but I have a record of the previous one in terms of the old exported shape files. Yeah, so this way it allows me to compare. So this is what the current scenario looks like, this is what the old scenario result looked like. Yeah, so I can compare this route with the old route one. Okay, so that's about it. Rest everything, you can supply more specific information for the orders and depots to, let's say, your hospitals and hotels, and similarly to the potential candidate location as to make it more realistic. And you can bring all that information using CSV file, join it and export it, and then use that exported file as the loading location for the orders and the depots, and then that'll make it a lot more easier for you to specify what field contains what information. Okay, so if you guys find it interesting and use it for your class projects for various different scenarios. If you guys have any questions, you know where to get hold of me. Thanks. Have a nice day. Bye bye.